Hello dear students, next chapter for the LEP study material 12th class chemistry, that is a chapter the coordination compound. So let's start from the first question, that is a MCQ type question. So the first question is vitamin B12 is the complex of cobalt, zinc, vanadium and nickel. So right answer that is a cobalt, because vitamin B12 that is a complex molecule containing cobalt atom in its the center. Second, that is a nickel cyanide 4 2 negative, that is a geometry. So first square planar and diamagnetic, tetrahedral and paramagnetic, square planar paramagnetic, tetrahedral and diamagnetic. So right answer that is square planar and diamagnetic. So reason is that in case of a nickel, that is a atomic number, that is a 28, that will give electronic configuration 3d8 4s2. So in the ground state, this is shown here in the nickel 2 positive, and by losing the 2 electron, that is a nickel 3d 8 positive. So after the cyanide molecule approaches, cyanide ligand that are approaches, so due to that there is a formation of 4 vacant orbital are created, and formation of that is a dsp2 hybridization. So there is a 4 electron pair donated by the 4 cyanide negative ion, and this will show that this is a diamagnetic and square planar complex. So magnetic behavior, this is a diamagnetic and no unpaired electron is present. Next, what kind of isomer exists between the chromium butter 6 Cl3, so Cl3, and what chromium butter 5 Cl2. So here we can easily see that the Cl negative Cl3 and here Cl2 and butter molecule. So there is a different number of ligand present inside the closed bracket and outer side the closed bracket. So the right answer that is a solvate isomer. Next, that is a in case of platinum ammonia NH3 2Cl NO2, that is a the right name. So first we have to find the oxidation state. So as we consider platinum, that is the X, NH3 ammonia 0 field ligand having 0 valency, Cl 1 negative, NO2 1 negative, that will give X equal to +2. So the name is that is a diamine chlorido nitrito N platinum, that is a platinum, and N platinum 2, that is a oxidation state. So right answer that is a C option is the right answer. Next, which has a maximum number of unpaired electron. In case of zinc 2 positive, iron 2 positive, nickel 2 positive and copper. As we know, zinc that is a 3d10 4s2. After loss 2 electron, that is a 3d10. So in case of iron, that is a 3d6 4s2. After loss the 2 electron, that is a 3d6 electronic configuration, that is a 4 unpaired electron. And in case of nickel, that is a 3d8 4s2. So that is a 3d8 having the again 4 unpaired electron. In copper, that is a 3d10 4s1 after loss of 2 electron. Sorry, copper, that is a 3d10, there is a no unpaired electron. So maximum number of electron that is exists in the so here there is a problem, that is a nickel, that is a 3d8 unpaired electron, so only remaining 2 unpaired electron ਰਹਿਣਗੇ ਇਹਦੇ ਵਿੱਚ. So in case of iron, that is a 4 unpaired electron, this is the right answer. So iron 2 positive is the right answer. Next, the oxidation state of iron in K4 FeCN6. So as we know, in case 4 into 1 K potassium and iron X plus 6 cyanide into -1 valency, that will give X, that is a 2 plus 2. So hence plus 2 is the oxidation state. Next, the primary and secondary valency of platinum E into Cl2 are, that is a 2 and 6 are the valencies. Next, which of the following has square planar structure, that is a nickel Cl4 2 positive, nickel CO4, nickel CN4 2 negative, none of these. So this is a nickel cyanide, that is a nickel CN4 2 negative, sp3 having the square planar structure. Next, the correct IUPAC name of platinum NH32Cl2 is, so that is a diamine dichloride of platinum 2. So this is the right answer. As we know, first we have to calculate the X oxidation state. Ammonia, that is a 0 field ligand, Cl, that is a -1. So X की value 2 आ जाएगी, आप easily solve कर लवांगे. Next, which of the following has a strong field ligand? So strong field ligand are, that is the most electronegative element present at that are the most strong field ligand. So C, carbon, oxygen. So CO, that is a strong field ligand. This means that this will form a strong bond with this metal ions and causing a large separating of a d orbital in the metal ion. Next, an example of ambidentate ligand. The ambidentate ligand which having the two donor atom in a one molecule. So example, that is a amine, aqua, oxalato and thiocyanato. So example main correct, that is a thiocyanato, in which the S and N are both SCN or NCS can be written thiocyanato. So in which the nitrogen donor atom may be nitrogen or sulfur, that will exist in, that is a ambidentate ligand. Next, how many donor atom can EDTA? So EDTA, ethylene diamine tetraacetate. So in case of EDTA, total 6 donor atom are present. So next, what is the shape of coordination polyhydrogen of platinum Cl4 to negative? So this will also, that is a square planar geometry. Next, oxidation state of nickel, again CO4, that is a nickel CO, that is a 0 field ligand. Again X, that will give a 0, that is a 0 field ligand. Oxidation number of chromium in potassium CrCO4, that is a, it will give X, that is a -1. So -1 is the oxidation number. Next, which of the following compound is not a linkage isomer? So the isomer first, that is also type, second, that is also type, third COCl2En2, this is not a linkage isomer. Next, the compound CONH35ClSO4 and CONH35SO4 and Cl, this is the interchange of primary and secondary valency or ligand. So these type of also called as the ionization isomer, because that will give the different ions of primary secondary valencies. Next, hemoglobin is a complex compound which contain the metal ion, that is a iron 2 positive ion. Next, the oxidation state of cobalt in potassium COCO4, that is a, that will give +1 plus X plus 0, that it will give the -1, that is a C option is the right answer. Next, ethylene diamine is an example of, that is a bidentate ligand, this is the right answer, ligand example. Next, that is a the oxidation state of a nickel nickel carbonyl so4 is 0. So this is a right statement. FeCO5 is a most stable because CO is weak field ligand. This is a false statement. So the energy difference between the set of d orbital, that is a crystal field separating energy, that is a true statement. FeCN 6 3 negative ion show magnetic moment corresponding to 2 unpaired electron. This is a false statement. NiCN4 2 negative, that is a square planar, true statement. Chelate complex tend to be more stable, also true statement. 2 nitrogen and 4 oxygen are donor atom in the EDTA ethylene diamine tetraacetate. This is also true statement. Due to that, there is a 6 donor atom. So the primary and secondary valency of copper in the complex Cu NH34 SO4, that is are 2 and 4. This is also a true statement. Next, that is a 2 marks carrying question. So define ambident ligand. So the ligand or the molecule that can be bond to a metal ion through two different atoms. So that can be thiocyanato through sulfur or nitrogen, that is a 2 donor atom which can form coordinate bond with the central metal atom. Next, write the factor affecting the stability of complex ion. So major factor, that is a charge density, size of the metal ion and geometry of complexes. So charge density, higher the charge density, geometry leads to the more stable complex. This is because the metal ion are more effectively attract the electron of the ligands. Size of metal ion, smaller the metal ion tend to form more stable complex and large one. So third, the geometry of complex, the arrangement of the ligand around the metal ion can also affect the stability of a molecule. So next, the important difference, that is a strong field and weak field ligand. Weak field ligand are mostly paramagnetic, strong field that are diamagnetic. Weak field ligand that can result in the low crystal field splitting. Strong field ligand is that can result in the higher crystal field splitting. They are also called as a high spin complex, and these are the low spin complex, never formed by Cn negative ion. This is a strong field ligand formed by the Cn negative ion, Co negative ion, No negative ion, NO ions. Okay. Next, the IUPAC name of the following. First we have to calculate, that is a oxidation state. In case of CO, that is a X plus 4 into 0 ammonia 0 field ligand plus 2 into water, that is also 0 field ligand, plus 3 into Cl negative charge ligand. So इथों आप X कैलकुलेट करांगे 3 आ जाएगा. So the name is tetra amine diaqua cobalt 3 chloride is the right answer. Next Cr En3Cl3. So first oxidation state कैलकुलेट करांगे तो X वैल्यू साढ़े को 3 आ रही है. So the name is ethylene diamine chromium 3 chloride. Next, that is a platinum Cl2En2NO3 2. Again X पहले कैलकुलेट करांगे. ethylene diamine, that is also a zero field ligand. ठीक है. So X वैल्यू इतने 4 आ जाएगी. So डाईक्लोरो bis ethylene diamine platinum 4 nitrite. ठीक है. So next, that is a K2 palladium Cl4. So first X कैलकुलेट करांगे आप ऑक्सीजन स्टेट, that is a 2. So that name is a potassium tetrachloropalladate 2 ions. Next, that is a two different metal ion. So that is a ferric hexacyanoferrate 3 is the right answer. Next, the IUPAC name of complex. So pentaamine nitrito N cobalt 3. So complex name is CuNH3 5 NO2 Cl. Next, that is a tetracarbonyl nickel 0. So nickel NiCO4. Next, that is a tetra hydroxido zincate 2. So ZnOH4 2 negative. Potassium trioxalate, that is a chromate 3. So the name is KCrC2O4 3. Next, that is a hexamine cobalt 3 sulfate CuNH362SO4 3. Next, define denticity of the complex. The denticity of a ligand is the number of a donor atom that can use to bind a central metal atom. The denticity. Bidentate ligand has 2 donor atom, tridentate has a 3 donor atom. Next, that is a homoleptic complex, that is the chemical compound where all the ligands bonded to the central metal atom are identical. This means that the ligands have the same chemical composition and structure. Name the central metal atom present in the hemoglobin and vitamin B12. In case of hemoglobin, that is a iron. Vitamin B12, that is a cobalt, is the central metal atom. So similarly, next, the following complex again. First, calculate oxidation state, then name potassium dicyanoargentate oxidation state 1. So similarly, second, that is X calculate करेंगे, that is a tetraamine diaqua nickel 2 sulfate. Next is the difference between double salt and coordination compound. Important difference है. In the double salt, they exist only in the solid state, and in aqueous solution they dissociate completely. Sorry. In coordination compound, that exists in the solid as well as liquid. In double salt, the metal ions show normal valence. In coordination compound, metal satisfy all two types of valency, primary and secondary. Double side lose their identity in the solution. Coordination compound retain their identity. Double salt have ionic compound and do not have any coordinate bond. And in case of coordination compound, they may or may not have ionic compound. The complex part always contain coordination bond. Next, low spin and high spin. Low spin complex are the coordination compound containing paired electron and low energy field, and high spin complex are the coordination compound complex containing unpaired electron and high energy levels. Low spin, most square cylinder complex are low spin. Mostly octahedral and tetrahedral compound are high spin. So these are the most important chapter and important question given by the learning enhancement program by Punjab School Education Board. So all the best to all the students and get good marks. So अगर भी सारी ਜਿਹੜੀਆਂ ਵੀਡੀਓਜ਼ ਹੈ ਤੁਸੀਂ ਸਾਰੀ ਵੀਡੀਓਜ਼ ਨੂੰ ਫੋਲੋ ਕਰਦੇ ਹੋ, ਠੀਕ ਹੈ, ਸਪੈਸ਼ਲੀ ਟੌਪ 10 ਦੇ ਸਾਰੇ ਚੈਪਟਰ ਅਗਰ ਕਵਰ ਕਰਦੇ ਪਏ ਹੋ ਤੁਸੀਂ, ਪਲੱਸ ਇਹ LEP ਦੇ ਸਾਡੇ ਸਾਰੇ ਹੋ ਜਾਂਦੇ ਆ, ਐਂਡ ਜਿਹੜੇ ਵੀ ਪੇਪਰ ਸੋਲਵ ਕਰਕੇ ਪਾ ਰਹੇ ਹਾਂ ਆਪਾਂ ਸਾਰੇ ਕਰਦੇ ਹੋ, ਤੁਹਾਡੇ 70 ਆਊਟ ਆਫ 70 ਮਾਰਕਸ ਡੈਡ ਸ਼ੋਰ ਹੈ। ਸੋ ਆਲ ਦੀ ਬੈਸਟ ਟੂ ਆਲ ਦਾ ਸਟੂਡੈਂਟਸ, ਥੈਂਕ ਯੂ।